Hello, Griffins. Mr. Milks here with video number 4 for periodic table. Today we are just going to get into the rows and the columns. There should be one more quick video. Enjoy it while you got it because the next one's going to be long. But that's all right. Video 4. Electron shells and period organization. Each period represents the number of electron shells, orbitals, or energy levels. Those three terms are synonymous. That means they mean the same thing. So I can use any one of these words and I mean the same thing. Energy levels is orbitals, is electron shells. And not only will I use any of those words interchangeably, I'm sure New York State will also. So you need to be prepared. Okay? Elements in period 1 have only one shell of electrons. Elements in period 2 have two shells of electrons, and so forth. So there's a nice little piece, and we can see that too in the electron configuration. We started in on that last unit, right? The electron configuration shows us how many actual energy levels are in there and how many electrons are in each. Okay? The properties of the elements. Oops, quick, Mr. As I go from left to right, you are adding one more electron to the energy level, which changes the properties of the element. But notice I don't change the number of energy levels. That electron I'm adding goes into the outermost energy level that I have. The left side of this periodic table is all the metallic elements, and the right side is the non-metallic elements. And we talked about the staircase a little bit in the vocab video. We will highlight that more when we get into metals versus non-metals. Each step to the right leads to a more non-metallic property. So as I go right, I become more non-metallic, or I become less metallic. Either way you want to say it, it means the same thing. Non-metals are on the right. Groups. As I go up and down, the last electron is added to the element on the outermost energy level. We call those valence electrons. As I go down the group, all the elements in that group have the same valence configuration, the same number of valence electrons. And because that is the case, they will react very similarly. Even if there's that extra energy level, it's only got one valence electron, or it only has two valence electrons, or they all have 7 valence electrons. They're all going to tend to react the same way because everybody wants to get to 8 one way or another. Okay? The properties do not change as I go up and down a group, and that's because we call them families. They are very physically and chemically similar because of this valence number of electrons. This is especially true for groups 1 and 2 and for groups 17 and 18. There's variation pretty much in everybody else, but those are the 4 families that we deal with. Ready? Alkali metals, alkali earth, halogens or halides, and noble gases. Those are our 4. Okay? And a little reminder about Lewis dot diagrams. It's just a symbol with its valence electrons. Remember, the first 2 go together, then one at a time around the bus. And we only deal with valence electrons because that's going to help us predict the properties of said atom. Okay, valence electrons helps us understand that kind of thing and becomes very predictable. And there we are. We're done with another short video. I hope you enjoyed one short one because this next one's going to be long. You just finished page 7 of your notes. If you need to rewatch the video, by all means do that. You're going to complete the questions in your Google Classroom assignment and hit done. So Mr. Milks knows you've done it all, and then you're going to come to class prepared to do 8 and 9. Whatever you can try to do now after watching that would be great. And otherwise, we will finish up tomorrow in class, and I will see you then.